Hi לכולם, hi לכולן, hello everyone. I'm going to do the intro part in English, part in Hebrew, בגלל שיש לנו פה אורח מחול שבא לעשות את ההרצאה. So hello everyone, and thank you so much for joining another meetup by Angular IL. So we have today 3 talks by Daniel Tamir, Manfred Steyer, and Nir Kaufman. We will start with the talk by Daniel Tamir. Yeah, that's my cat in the background. לפני שנתחיל, שימו לב שהולכת להיות הגרלה. אני הולכת לפרסם למטה קוד, צריכה כתובת להיכנס להגרלה, לכרטיס חינם לאנגולר אפ, ושתי רישיונות של JetBrains, אלה שעושים את WebStores, שתוכלו לקבל רישיון לשנה. ועוד משהו חשוב לפני שאנחנו מתחילים, המיטאפ הזה בעצם נוסע על ידי 500 טק, שזה פרונט-אנד קונסולטנסי בישראל, שכרגע מגייסת, זה לא קורה הרבה, אז עכשיו יש לכם הזדמנות נפלאה להצטרף ל-500 טק, מוזמנים ליצור את הקשר לפרטים. So without any further chit-chat, I'd like to introduce you to Daniel Tamir. היי דניאל, מה הולך?
Hey everyone.
תרצה לשתף מסך?
Yeah, let's do this. So share screen and 1 second, I need to allow the second one. Can you see the presentation right now?
עוד רגע, תשתף מסך.
1 second. Lost permission to capture the screen. So one second, I need to allow the permissions.
Please hold. Your call is important to us.
Mm-hmm.
Yeah. So while you're uploading your screen share or whatever, do you want to tell us a little bit about your? Oh, there we go.
Now it's okay.
Now we see it.
Yeah.
Have fun.
Thanks. So, hello everyone. So today we're going to talk about Angular unit test tips and tricks. And we have a lot to talk about, so let's get started. First of all, I will introduce myself. My name is Daniel Tamir. I live in Israel, in Rishon LeZion. Father and an husband to the cute guys you can see in the picture. And I'm a front-end technical leader and guild master in Tufin. So what is going to be our agenda for today? We'll start from not convincing you for writing tests, because you already know you should write tests. I'm not going to teach you how to separate your tests or to teach you testing methods. What I'm here for is to live code with you together and show you some cool examples and usages that will help you for writing tests. Now, we're going to see some examples and overview some subjects. So let's see our plan. We'll start to talk about spies, okay? Spies are used to track or stop functions or methods. And spies are a very easy way to check if a function was called. Okay, check its arguments, providing values, and many other things. Then we'll learn to test the elements, okay? Elements interactions. So we'll check if the element renders, check its attributes, check their events, and many other stuff. We'll learn to test directives, okay, using test components, and testing pipes. We'll learn to test the HTTP. And then, in the end, we'll learn how to create a very cool code coverage tool that will help us to identify where we missed out in our test. So I already said that this is going to be a live coding session, so let's start with writing code. So this is our application, okay? This is an Angular application, very basic one, without a lot of content. And we have some components, directive, pipes, and services that we'll test during the way. What I did is simply ran the ng test script and the test ran for the code I currently have in the application. And I will delete this one, we will need it later on. Cool. So let's look on our components. This is our component called playground component, very basic one. As you can see, it has an ng-on-init lifecycle, which calls to being called first function. Being called first function calls to being called second and initialize the company name. Then being called second changes the company name and calls to console log. But before we drill down into the component logic, I want to focus on some small part of the code. I want to focus on these 3 lines. ng on init simply calls to being called first function. And this is exactly what I want to check. I want to check that once someone calls to ng on init, being called first was called. And let's go to the spec files where we write our tests. This is a basic spec file that is automatically being generated when you create a component. And with the testbed, okay, the testing model, declaring the components, creating the picture, and the component instance that we will use in our tests. And probably you all are familiar with it. So as I said, we'll start with Spies, all right? So this is where we start our Spy. Now, as I said, I want to...
Can you just like zoom in a little bit so I can see a little bit better?
Yeah, this is better?
Awesome, thank you so much.
Yeah, cool, thanks. So as I said, I want to focus on these 3 lines, okay? ng on init calls to being called first. So in my test, just a small recommendation, when you build your test, it's really helpful to follow the arrange, act, assert part. So you first arrange the parameters you would like to check, then you act, call to the method, do some other things, and then you assert. So let's say our end result should be something like this, right? The assert part should be something like expect. This is where we write our expectations. So the component being called first to have been called, right? This is what we want to check in the end. I'll close this one so we will have more room. So let's save it. Okay, we got an error. Expected a spy, but got a function. So this pretty much tells us that we need to declare the spy for being called first because we want to check that it was called. So the syntax for creating a spy is spy on. The first argument is which class do you want to spy, and the second one is which function do you want to spy on. Great, so we added our spy. This is the arrange part, right? Let's save. Expected spy being called first to have been called, but it wasn't called because we missed one part in the text, right? So component ng on init. Great, so we have a passing test. We call to ng on init, and we check that being called first was called. Now let's go back to the components. So we check this part. But now I want to check that being called second was also called because being called first calls to being called second, right? So let's duplicate the spies and call to being called second. And I want to check that being called second was called. Should work, right? But it's not going to work, and I will tell you why. Because when you spy on a function under a class, the spy automatically stubs the function you are spying on, and it doesn't have the original logic it previously had. And if you want to spy on a function and both to call its original logic, you do something like this and call true. It means I want to spy on a function and I want to call its original logic. So as you can see, the test now passed. Now let's go back to the components. So we checked that ng on init was called, being called first, and being called second was called. Now, can you guess what is the company name right now? So let's say if I reset the company name, and I write expect component company name to equal, let's say, to thing. Okay, so we failed because expected not to fin to equal to fin. Why? Because you remember we said that once we spied on being called second, we no longer have this logic. So if you want to have this logic, we should go through it again. Now the test should pass properly. Another thing you can do with Spies is checking how many times the function was called. So you can do it using 12 being called times and simply give it a number. Okay, now everything is good, but if I will go to the component and simply duplicate this line by accident, the test will pass because it will check that it was called once and the original call was 2 times. So let's remove this. And this is how you can check how many times the function was called. Now let's drill down deeper. Being called second. Being called second, once we call to the function, we call to console log, right? So console log is being called with the return value from isRing Angular developer function. And isRing Angular developer function simply returns the string, all right? And this is what we want to check. We want to check that once we call to being called second, console log has been called with the return value from isRing Angular developer. So let's do this. You probably guessed it. We should spy on console log. We don't need this one. And we want to check that console log now we used to have been called with. Okay, now we give a parameter to the function to check with which parameter the function was called. Let's put it empty for now. I want to see how the test fails. So expected spy log to have been called with nothing, but the actual call was to fin isRing Angular developer. So let's copy this string and paste it in the test. So the test will pass. Okay, now the test passed. And this is how we check how the function is being called, okay, with which parameters. Now, I want to show you some other thing. isRing Angular developer is a function which simply returns a value. What if I want to spy on the function, on isRing Angular developer function, and whenever someone calls the function, I want it instead of returning the original value, I want it to return some other thing. So let's do this also. I want to spy on component, isRing Angular developer, and I want it to return a value. I want it to return a value, let's say, higher. And say send your series. Let's see how the test behaves. All right, so now, as you can see, the actual calls were send your CVs. So we spied on the function, and someone calls it, and instead of returning the original value, it returns a fake value. Now, this is a very useful tool, because imagine you have a function or a class, and you know that the class is behaving as you want it to behave, and you have the test for it. But in other tests, you simply want to check that this function or class was called. So you don't really care about how it behaves. So this is a way for simply mock the return value from some function. And so this is a very useful tool, but you should know that you can write it in another way. So instead of returning a value, you can use the call fake. And call fake, it simply gets a function, and you can write every other function you want and to return it. So let's fix the test. Cool. So we learned about call true. We learned about to have been called time, to have been called with. Okay, we saw how to return a value and to call fake. And the last thing I want to show you about Spies is a very useful tool. Let's say I want to store the spy. Okay, now the spy returns an object. So now I have the spy object in my hands. And by containing it, I can simply check that being called first, have been called before, and I need to give it a spy. Now I check that being called first was called before the second spy. So I can check that the function order in addition. This is all I want to show you about Spies. I hope you learned about new ways. So let's continue to the second topic for today. By the way, all the application will be uploaded to GitHub, so you can get all the tests and the examples. So you will be able to use it. So the next subject is element interactions. Now, if you want to interact with elements, we should have elements. And right now we don't have it, so let's go to the components and create some very simple elements. Create a button with beacon and beacon primary. And let's say I want to call it alert company. And I want to create another div with a class of company name. And I want the div to have an ngIf. And I want it to be rendered in case we have the company name. And I want it to have an ng class. And I wanted to add a class of Tufin in case the company name equals to. So we have very simple two elements. One is the button, and the other one is simply a div with some attributes. So let's focus on these elements. So this is what I want to test right now. The first thing I want to test that when company name is given, the element renders. When it's not, it's not. And the second thing I want to check is when the company name equals to Tufin, a new class is added to the element. Okay, and I want to show you how to check like any other thing under the element. So let's print the company name just for having it. Cool. So going back to our tests. So the first test is going to be very simple, right? It's going to be an if and should properly enter company name element when it's given. So one thing you should know, I'm zooming out just for you to see, I hope it's okay. One thing you should know about when you're interacting with elements is, firstly, you should get the element using a CSS selector. I hope you all are familiar with it. And let's start from the self part. So in the end of our test, we would like to check something like this, right? So company name L and not to be null. Okay, the test will fail right now because we don't have the company name. But in the end, we will have it, so let's get it. So the first thing, as I said, when you're interacting with elements, you should get a selector. So selector. And the selector for company name elements is company name. And pay attention to the dot in the beginning for classes. And then we should get the company name element, right? But just remember that the company name element renders only in case we have a company name defined. So let's define it. And let's say not Tufin. Okay. So we have the company name defined. Now we should get the element, right? So const, let's use what we want to achieve in the end. Now we use the feature, okay? As you saw in the beginning, we have the feature, which is the component that we are currently testing. So we can use it for querying for the native element and the debug element. We'll talk about it in the session. But native elements are pretty much the DOM elements in your components. So feature, native element, and native element as a function, as a method for query selector. And you probably guessed it, query selector gets a selector. So it gets the company name selector. But because we changed something under the component, we should let Angular know that something was changed. So we should check, we should trigger the feature detect changes. So this is the act part, right? And this is the arrange part, where we arranged our component. And so let's run the test. Great. So the test passed. Let's see if it really functions. Let's check that the element is null. Okay. Expected element to be null. So the test works. Now let's check the other case. Copy the text. Should not render company name when it's null. I don't know. So now let's change the company name to be null. And let's run the test. Okay, expected null not to be null, because now the element is gone, right? We don't render it. So we don't need to check it. And now we have two tests. One that checks that the element renders, and the other one that checks that the element is gone. But we have another test, right? We said we should check that once the company name is Tufin, we should check that the element has a class of Tufin in it, right? Because we had ng class that has a Tufin class in case the company name equals to Tufin. So this is exactly what we are going to check right now. Should probably add Tufin class, and when so we set the company name to be Tufin, we detect the changes, we got the elements. The element is not null, right? The test will still pass. But now I want to check some other thing. I want to check that the class list, to include, to contain thing. We added a class, conditional class, for using the ng class. All right, it's still class. Let's check the other thing where the company name is not Tufin. See that we're really checking something. Great, so we have a functional test. And I can check pretty much, as I said, this is the native element. This is the DOM element that you have under the component. So you can check everything that the native element is giving you, like styles, like the text context. Let's check that the text context contains Tufin, or more to be accurate, to equal. Okay, so using the native element, you can check pretty much everything under the element itself. But now I want to show you some other thing. Do you remember in our component, we had a button, which is an alert company, right? So let's add a click method, a click event to it. And once someone clicks it, I want it to call to a function. Let's fix it. I want it to call to a function which calls alert company name, which pretty much does the basic thing of alerting the company name. This is what I want to check. I want to check that once someone calls to this function, alert is being called with company name. Now, we learned how to do this, right? We are using Spies. So let's write this test. So it should properly call to the company name when the button is clicked. Something like that. But let's do this. So first of all, we need spy, right? Now we are spying on the window, and we are spying on the alert method. And you probably get it. This is the arrange part. So we spied on the alert method, and now let's go to the component alert company name. This is the act part. And now let's write the assert part. The assert part is, we know how to do this right now. So window alert to have been called with component company name, because this is what the function does, right? It alerts the company name. Now the test passed, but it doesn't actually does what I wanted to do. As I said before, I wanted to test that once someone clicks on the button element, it triggers the alert company method, and then alerts it. So let's do this. Let's look on the elements. Let's say Now, as I said before, when we interact with elements, we should get elements using a selector. So our selector is in this case. Right? We go for the cyclic selector. So we have the selector. Now we need to get the element. Right? So alert button, alert company name button. That's it. So now we use the picture. Now we don't use the native element. And I want to use the debug element because the debug element is giving you a much richer API for interacting with elements to trigger events or trigger something. And let's see what it can do. Now, under debug element, you don't have the query selector. You need to use the query method, which gets a predicate. And the predicate gets, you can get a selector using the by CSS. And for those of you who wrote the test using Protractor or some other Selenium-based frameworks or Cypress, you get the element using the CSS selector. And then we have the alert company name button. Now we can use the element that we have in the end and use a method which is called trigger event enter. Trigger event enter gets two arguments. The first one is the event name. So we are using the click event. And the second argument is which object do you want to pass to the event. Now, we don't really need to pass anything because we simply want to simulate the click, right? Let's save. All right, the test passed, but that's cheating, right? We have this function. So let's remove it. And the test still passed. Pay attention to the test. We check that once someone clicks on this element, it triggers this function, and we check this logic inside of it, which means that if someone accidentally remove this element from your HTML, your test will will fail. Okay, so this is a very good way to protect your elements logic. I want to show you some very short tool tips. Let's say we had something like this. So we have a set timeout method, and let's say I want to alert, use the same logic that we have in the original function, but after 500 milliseconds. All right, the test will fail. Why? Because Jasmine automatically, when it reached the assert part, it triggered it right away. And this function, this logic opens only after 500 milliseconds. So let's go back to the test. So in our test, we somehow need to simulate the time, right? We need to make the time pass. So this is exactly what we are going to do. So let's do this together. Let's use the error function. And one way to do it is using the fake async. Fake async is some method that helps you to simulate an asynchronous passage. Okay, it helps you to pass the time to check your logic. So once I use the fake async, I can simply do something like this. And do you remember in the component we used 500 milliseconds for the logic? So here I can use a tick. Right? Now the tick gets a number of how much milliseconds do you want to pass before we trigger the next step. So right now we use 499. Something is wrong with the home browser. Let's refresh it. Now it's okay. Let's rerun it. It will take a second, but let's talk about it. So now we ticked 499 milliseconds. So basically, the test shouldn't pass right now because we didn't simulate enough time for the test to pass. Now let's return it to the same state. OK. Cool. So now the test didn't pass. But what if I give it the time it needs? OK, so now I gave him the time he needs for the test to pass, and now we simulated half a second of the time, and now we can check logic for set timeouts, set intervals, or other things that you need to simulate time for. So this is how you test it. Another option for you to test it is using the run function. I need it. So when you provide to the test the done function, you can pretty much control the test. And you can tell Jasmine when to end it. So we don't need this one. And now we can use the set timeout here in the test. Now we want to check it. We want to check it after 500 milliseconds. Now the test will fail because no one told Jasmine to finish the test. But if we tell it when to finish the test will pass. The difference between the two methods are that the fake async really fakes the time, and you don't really have to wait the 500 milliseconds. Here, the test actually waits. So I don't really like this option. Try to use the first one, but just know it exists. OK. Great. So this is all I want to show you about elements interactions. Let's move to the next subject. Pipes or directives. Let's start with pipes. OK, so we have a very, very simple pipe. We don't need more than 2 minutes to cover the test. Pipes, one thing you should know about pipes, that pipes are classes, nothing more. And once you get the class instance, you can do everything with it and check its logic. Because the pipe has a transform function, and you can check the transform function. So let's see. So our test is empty. So all we need to start writing test is the describe. Let's select it. And let's call it the pipe. The employee name. So this is our describe. And now we would need to write test. Right. So this is our test. Should properly transform the value. This is all we need. The first thing we will need is getting the component, the class instance. OK, the pipe class instance. So employee name pipe equals the new employee name pipe. Okay, now we have the instance. And now we can use something like this. Transform value to equals to transform and angular. Write something like this. So now for the expect part. You should expect that the transform value to equal to, let's see, the pipe. So it gets the value and then adds rocks to it. So what should we should expect something like this, angular box. Right? Great. So we are still good. All our tests are passing. So this is how you can check your pipes. Directives. Now, let's see our directive. We have a very, very simple directive here. OK, highlight directive, which gets the element, OK, elements where we want to put the directive on. And it has two host listeners. OK, host listeners are something you can host for reference and do some logic on your directive. So when we use the mouse enter, we highlight the color for red. And then when we use the mouse leave, we simply remove the color. Pretty simple, right? One advice I can give you about testing your directive is using a dummy component. okay, a dummy class. And so this is exactly what we did here. We created a very lightweight dummy component, which is simply a div, okay, which has the directive that we saw in the first place, and it has some text. So what should we check here? We should check that once we trigger the mouse enter event, it's painted in red, and once we leave it, it's painted in nothing. Okay, go back. Now, we learned how to do this, right? We know how to do this, because when we interact with elements, we should get first the default. And our selector is this one. So now, after we have the selector, we should get the element. Right? So the element, as we saw in the beginning, so we are using the debug element because right now we want to trigger events on our elements and to check it. So debug element, query, you should probably know how to do this right now. And we are using the by CSS. And we are getting the selector. Now we should check two things, right? So EL, trigger event handler. The first one is the event name, right? So the first event name is mouse enter. And we don't need anything else. And the second event is mouse leave, right? Now, what should we check? When we mouse enter, we should check that native element. As I said before, native element is the way to get anything out of your DOM elements. So style, color, to equal red. And when we mouse leave, let's keep it like this. I want to see that the test really does. And let's see, mouse leave. What's it on here? Something is not doing its job. Let's find the test from the beginning. Mouse leave. Yeah, we named the event properly. That's weird. Maybe should then take changes. Let's keep it like this. Something is wrong here. Element to highlight, and we got the element using the debug element to contain. That's weird. Oh, debug element. Oh, crap. We have the X describe. So we didn't really check anything in the suite. So now our test really fails. So now we can simply remove the color. And now our test is doing its job properly. So this is how you can check directives, all right? So you can trigger events, you can use the test components, and you can check the directives logic. And you can cover it also. Now, I want to show you some really short example of how to test HTTP, and then I will finish. Now, let's look on this service. So we have a very simple service, right? We have two functions. One is get employee list, the other one is delete employee, which simply uses the HTTP with a URL. It gets the value back and is using a pipe to transform the return value into its data. So what do we want to check here? If we want to cover it using HTTP, first of all, we want to check that we are using the get method, right? And then we want to check the URL, okay? Because we want to check that the URL is really correct. Then we want to check that it gets a return value and map the return value to its data. Okay, we want to cover the entire line. So let's learn how to do this. First of all, something you should know about HTTP. When you use HTTP client, you should import the HTTP client testing module. And then you should provide it, because we'll need to use it when writing our tests. Other thing you should know is it's a very good practice to use the HTTP verify after every test, because you should check that you don't have any requests that are pending. So let's start writing our test. So we want to test the service, right? And we want to check the get employee list. Get employee list is calling to the API, return the value, map it, and this is what we want to check. Now, I want to use the pipe because when we subscribe to something, I want it to kill itself after one time. And then we subscribe. Yes, that's saying all of that. Now, this is the employee. Yes, right? This is what we get back from the server. And what we would like to expect here is to expect that employee list, the return value, equal to some object, right? Some arranged object. So I want to show you what I prepared for this test. So we have mocks for, this is a constant that simply mocks the return value from the API. This is how the data gets back from the API. We get the data and we have the success. So the data is, we get something like this. So this is what we want to check, that once someone calls to the API and gets the returns object like this, I want to check that it maps it to something like this, because this is the data. So let's copy it. I'm back to the test. So I want to check that once I subscribe to the get employee list, we get the data, we map it, and it should equal to the employee list sample, the arranged one. Now, you can see expected no open request, found one get, which this URL, this is what we are going to check right now. So when you are testing your HTTP, you should get your request. So our request is HTTP, as I said before, we need to use the HTTP testing controller. And we should expect that we will call one time to the URL that get employee list is calling to, this URL. Okay, test now passed, but now we can do some other things using the request. And let's request. And now let's use the flash. Flash, what flash does is pretty much taking the HTTP, whatever you call it with, and flashes a return value to it. So now if we will flash the full data, the one that gets back from the API, this method, this expect will get the data as it returns from the API and check that it transforms properly using the map. So if you write something like this, now you can see that it expected the actual returned mapped object, but it got null. So we saw that the get employee list was triggered. We got a return object using the flash, and we checked the mapping, and it should be the employee list sample. So we checked that the mapping is working, and we call with the correct HTTP URL. The last thing we should check is the get, right? We want to check that the method we used is get. By the way, I'm finishing in. And this is it, okay? This is how you can check your HTTP clients. Okay, the last thing I want to show you, and it's going to be 1 minute, how to check your code coverage. This is a very super useful tool for knowing how you cover your code. So how to get the coverage? the report. One way is if you go to the package JSON, the default script for running the test is ng-test, right? You're all familiar with. But if you give to the ng-test method the -- code coverage and you run it, let's run it. What you will get back is a very useful coverage tool report that will let you know. I will close this one. That will let you know how you covered your code. So once you run it using the -- code coverage, you can see a folder, right, for coverage. And inside of the coverage, you have an index.html file. And if you open it using Chrome, you can see how well you covered your code. As you can see, we have a very good coverage because we pretty much covered everything in our code, but we missed something, right? We missed something in our services because we see that we don't have the 100%. So let's check what we missed out. As you can see, the code coverage tools let you know which part of the code you missed out because we don't have tests for delete employee, right? We checked the get employee list. So this is how you can track where you missed out and to get a better coverage of your code. Now, the last thing is, this is how you run your test on every library that you have. Let's say your project has multiple libraries, and you don't want to add the -- code coverage to every library. So in case you want to define it for your entire workspace or your entire Angular application, you can go to the Angular JSON and simply change the test, okay, under the architects, and change it to true. So now we won't need this script because we have code coverage for everything. That's it, guys. Let's go back to the presentation. So we saw how to coverage our code. The last tip I'm going to give you is automate your code. It will help you to ship in a much faster way and to know where you missed out and to track bugs in a more efficient way. And I will upload the entire project to this link. I will share it on Twitter, and I will share the presentation. And that's it, guys. I hope you enjoyed, and I hope you learned some new things.
תודה רבה רבה. זה היה ממש I will switch to English because we have English speakers in the audience. If you have any questions, just write in the comments, and Daniel will be happy to answer. Right now, I don't see any specific questions, but so you can definitely follow Daniel on Twitter and reach out to him, and you'll be happy to answer any questions you have. So thank you so much, Daniel. And now we go on to the next talk. Here's again is the code you can see below for the raffle for Angular free ticket and 2 JetBrains licenses. And let's welcome Manfred. Thank you so much.
Hello, hello. Thanks for having me. It's a pleasure to be here.
Yeah, okay, so let's see the screen. Let's see. Okay, with crazy Inception thing going on right now. Okay, so Manfred Steyer, thank you so much for supporting the Israeli Angular community. The stage is yours.
Okay, so thanks. So this will be about what I'm calling the micro front-end revolution, and it will showcase module federation, which is quite a new feature coming with Webpack 5. But first of all, let me ask you a question, namely, do you remember her? Perhaps you remember her, perhaps you have seen her. I give you a little hint, it's yeah, she was from Knight Rider, that's right. She was Bonnie. She was the engineer on the Knight Rider team. She was on the one side an electronical engineer and on the other side a computer scientist. And of course, she helped the Knight Rider team to win their battles with techniques. And she really inspired me back then because I looked at her and I thought, boy, I want to be such a person who can work with computers and electronics. And so she was one reason why I asked my parents to buy me a computer. I told them, well, you know, it might be beneficial for school, which was not true at all. At least it was not completely wrong, but it was not the full truth. But nevertheless, I got a computer and here I am. But when thinking back about Bonnie, one thing comes in mind that is quite funny. Bonnie was a one-man show, or let's say a one-woman show. And that's not the case nowadays. Nowadays, that's even not possible because nowadays, computer science and so software engineering is a team sport. You need to have several people with different knowledge, with different skills, and you have to coordinate them. And coordinating several people is hard enough, but in very much cases, you have to coordinate several teams. Software projects become that big that you need several teams, and of course, you need to coordinate them. And that's even harder. But there is one trick to accomplish that. The trick is about not writing monoliths, which can do everything, like cooking a coffee and doing your taxes and booking a flight. No, instead of this, we are splitting our huge systems into tiny parts. Tiny parts like a booking service when it comes to flights, like a check-in service, like a luggage service, and a boarding service. And those services should be isolated. The less they know about each other, the better it is. Because if they don't know much about each other, you can easily change one system without affecting other systems. That means you can assign one team to each of those services and they can work independently. In the backend, we are calling this idea microservices nowadays. The idea is much older, but in the last years, the term microservices was coined. And so people started to wonder how to use this idea in the front end. And this was the birth of micro front ends. A micro front end is basically the same. It is just a tiny piece of front end. Instead of producing a big front end, we are creating very tiny front ends and several of them so that one team can completely focus on one part. That works quite nicely, but the big question here is how to implement micro frontends. And honestly, there is a plenty of options for this. A plenty of options, but there was not the one perfect option. The one option supported by tools like Webpack or Angular or React. And that was quite a pity because we needed several tricks in the past. But now, with module federation, it is the first time we get a solid foundation for microservices from a well-known product, namely from Webpack 5. That means we get an official solution we can use to create such systems. And this is what this talk is about. I've subdivided this talk into two sections. The first section is the bigger one. Here I will talk about module federation. I will show you how to use it and how it works. And in the second part, I will show you a possible roadmap. Saying this, there is not an official roadmap, but I will use my glasses here to predict the future for you and also for me. Let's find out if this works. But first of all, let me introduce myself. I am Manfred. I am a trainer and consultant for Angular. I'm doing a lot of trainings and consultancies for companies nowadays. And in the last month, all of this was remote, which really works nicely. I was not sure before, but since I'm doing it, I can tell you this really works nicely. And I'm quite connected to the Angular community. I'm a Google developer expert for Angular. I'm quite proud of this. And I'm a trusted collaborator in the Angular team. And when it comes to the term collaborator, I always like to tell you one story. Namely, perhaps you know it, we in German have also the term collaborator. And it almost means the same as in English. It almost means the same, but always with a negative touch. Collaborating in German means teaming up with other people to destroy something. And well, if you look at my first pull requests I did for the Angular team, it was more of the German meaning. Meanwhile, hopefully, I've reached the English meaning. So I've already mentioned it. I'm doing a lot of stuff in the German-speaking area. I live in Austria and I do a lot of stuff in Germany. And I'm always happy when I can work together with international companies, when I can visit companies in other parts of the world, or if I can work together with them remotely, what is currently the case. Okay, cool. So let's get started with the first part of this presentation, which is about module federation itself. And I'm always saying module federation is a bit like the 1980s. You need to experience them, otherwise you don't know what they are about. And so let's get started with a demonstration. In this demonstration, I have here a so-called shell application. A shell application is an application capable of loading other applications on demand. When I'm clicking here, I'm getting another application loaded into the working area of the shell. This application is developed in isolation. It has been deployed separately, and it is located on a different origin. And from this origin, I'm loading it just on demand. As you see here, it even runs in standalone mode. And this is important because we want to test it, we want to develop it and to deploy it in isolation. So when we look at the network tab, we see this works a bit like lazy loading. I'm reloading everything, my shell is loaded, and when I'm clicking here on flights, then voila, you see that my bundle with the external application is loaded. Just on demand, here we got a bundle with the self-explaining name 798, and as you see here, it just has 3.1K. 3.1K, which is literally nothing. That clearly shows that this application does not bring its own version of Angular and also not its own version of other libraries. It is just bringing its own source code, and Angular itself, also other libraries, are shared with the shell. That means the shell is providing Angular, the shell is providing other stuff, and this micro front end is just reusing it. That's why it's that tiny. Perhaps you're saying now, hey, Manfred, that's not a big deal. Come on, this is lazy loading, and we know lazy loading. We are using it for years. And this is where I'm saying, well, it's not exactly lazy loading. It is lazy loading, but a bit more. For this, have a look at this URL here. Here you see localhost 5000. This is where the shell comes from. And when you look here, you see, yeah, right, localhost 3000. So it's really a different origin. That means I can deploy it to some other server, and on demand, I'm loading it into the middle of my application. So if we want to understand how this works, we have to answer one question. How is it possible to load separately compiled code from over there, from this other origin? And perhaps you are saying now, well, Manfred, come on, one more time. This is not that difficult because we have dynamic imports. ECMAScript 2017 gives us dynamic imports. And even before, we had require, the aaaand-based require, the CommonJS-based require. So that cannot be that difficult. Just use this mechanism to point to another origin and grab over there what you need. But the thing is, Webpack and so the CLI does not allow for this. Because Webpack assumes that everything is known at compile time. Everything needs to be there at compile time. Everything is compiled together. Everything is optimized. And then Webpack is doing chunking. Webpack is splitting off some chunks for lazy loading, but only then after compiling everything together. And that's why you cannot easily grab over to another origin at runtime. Of course, there are some workarounds for this, but there was not a sound solution in the past. Now we have Webpack 5 Module Federation, more or less. It's currently in beta, and Module Federation solves this. For this, Module Federation defines two roles. The first role is called the host. The host is the shell in my very case. And the second role is called the remote, which is the micro frontend in my case. The micro frontend I want to load dynamically at runtime. And then within the shell, I can use the Webpack configuration to map a route. I can say, hey, Webpack, you know, MFE1, which stands for micro frontend 1. Yes, I know, very creative. MFE1 is not something that points to our own project. It points to another project. And over there in this other project, it is also called MFE1. That means here I could create an alias. In this case, it's a non-alias because I'm mapping MFE1 to MFE1, but you've got the point. It could have the name Manfred or Batman or something like this over there, which is always a good idea. Please always call as many parts of your application Manfred and Batman. So this is just an alias. This does not tell you where you can find this other micro frontend, the URL of the micro frontend. For this, we have several options, and I will show you those options in some seconds. But first of all, let's stick with this. We are mapping some routes, and those routes will point to other parts, to other locations. Within the micro frontend, the remote, we can expose files. Here I'm exposing my CMB TS as the name CMB. That means another application, a shell, can load this CMB file. And then something beautiful happens. I guarantee you something beautiful happens. I'm using this import. So at first sight, and from the shell's perspective, this is just lazy loading, an ECMAScript 2017 import. But the thing is, this import is using a path I've mapped before, a path pointing over to another origin. And from this origin, I want to load CMB, which is exposed here. That means without knowing within the shell, I can load something from over there. This is completely agnostic to Angular or to the framework you are using. Okay, now you are wondering, how can we get the URL of the micro frontend? For this, we have several options. The easiest option is to compile the micro frontend, and when doing so, Webpack gives you a remote entry point. Just a tiny file, just a few bytes, it's not big. And then when starting the shell, you can load those few bytes into your browser using a script tag. Of course, you can also use a dynamic script tag. You can also reference the remote entry point with an API when starting the application. This is just one option, the script tag. By loading the script tag, the remote entry point tells the host where to find MFE1 and where to find all the other micro frontends. Perhaps you are wondering how to share libraries, and this is also quite easy. You can define a shared property in your Webpack configuration. If you go with the easiest option, this is just an array. It can be a bit more advanced. In this case, you can provide an object with a lot of metadata describing when and how to share stuff. But in the easiest situation, you just go with an array. And here I'm saying, hey, I want to share Angular core. And I'm doing the same over there. And when this is overlapping, then the micro frontend is reusing Angular core from the shell. If the shell is not providing Angular core, the micro frontend, it's loading its own version. That's why shared stuff is always put into separate bundles. This gives us the possibility to load it on demand. If the micro frontend finds out the shell is not sharing, then it loads its own version, which is quite smart if you ask me. One issue you will run into is conflicting libraries. Perhaps this is the biggest issue, the biggest challenge when it comes to micro frontends. Because when going with micro frontends, you are turning compile time dependencies into runtime dependencies, meaning they meet each other the first time at runtime, and perhaps they don't fit to each other because they expect different versions of the same thing. So for this, module federation provides several options. A first option would be to reuse the wrong version anyway. I'm calling this the ostrich strategy. You know, this big bird, the ostrich, who is putting his or her head into the sand until the dangerous situation passed by. This is what I'm doing here. I'm saying, hey, I need Angular 10. I'm only getting Angular 9, so let's trust in whatever, and let's assume it will work anyway. Perhaps it will work, perhaps it does not work. Anyway, it makes me feel like a runabout, a daredevil. The other option would be to load your own version. So perhaps you need RxJS7. The shell is only providing version 6, so you load your own version 7 in addition. That might be okay-ish when it comes to a tiny dependency, to a library like Rx or Lodash or something like this. But both might be bad when it comes to your leading framework or your leading library. It might work, and yeah, there are unsupported situations allowing to run several Angular versions side by side. But if you don't take care, if you don't know exactly what you are doing, you will fail. All hell will break loose. You will get a lot of exceptions. And of course, when loading Angular several times, this will increase your bundle sizes. And so it will decrease your startup performance. So please try to prevent this situation if it's somehow possible. So this might be okay, but when it comes to your leading framework, both might be bad. And so you are ending up with solving this by your own, by introducing conventions, like we are always using the newest version of Angular and so on, by using contracts, by using monorepos. A monorepo guarantees that you have more or less the same dependencies everywhere. You can go with integration testing to make sure that the runtime dependencies meeting each other for the first time at runtime work together seamlessly. And there is another idea: you could compare versions. That means before publishing a new micro frontend, you could look at the dependency versions of your micro frontend. You could look at the versions of the deployed stuff, and then you can compare it. Does it fit together? Is it compatible with each other, or will all hell break loose? Okay, so much for this. Now let me show you everything in action. For this, I will dig a bit into the source code of this application. And the first thing I want to look with you at is this roots definition. Here we see the roots of our shell. And at first sight, it looks like a traditional routing table, doesn't it? We have several routes, and one of it is a lazy route. It is using load children together with import, and import is loading something from another module file, and there we find an Angular module. So at first sight, it looks like all the times. And also from Angular's perspective, this is just a usual use case. But what we don't know here, especially what Angular is not knowing here, is that MFE1 is mapped in the Webpack configuration. It is mapped to an external application located on a different origin. completely agnostic for Angular, do the heavy lifting underneath. So to find out more about this mapping, let's have a look into the Webpack config. And here we see a lot of stuff the CLI is normally generating. And here we have this entry. We are using the module federation plugin. Here I'm mapping my micro frontend. I'm saying, hey, MFE1 points to MFE1 over there. I'm not saying what's the location of over there. I could do it. The newest beta version of this allows us to define here the location, but here I'm not hard coding it in the configuration. I'm defining this later when the application starts. And I'm saying, hey, I'm a nice guy. I want to share with you. I want to share those libraries, Angular Core, Angular Common, and of course, the router. This is what we need for our shell. Well, and when it comes to our micro frontend, our remote, I'm also using the module federation plugin. But now I'm assigning a name to this remote, a name to this micro frontend. I'm defining the name of the remote entry point, and I'm exposing stuff. For instance, an Angular module with child routes and an Ivy component. And of course, I'm also saying I want to share with the shell so that I don't need to load everything one more time. And that's everything we need. When we have this, when we compile this with Webpack, we will get a working solution which is fetching something from over there. Of course, when the application starts, we need to tell the Webpack runtime API about the location of our micro frontend. And for this, I could do a simple task like here. I could just statically import the remote entry point from over there. That's one possibility, just import it. Another solution would be to create this grep tag dynamically, DOM manipulations, and you can even use the runtime API of Webpack to define the micro frontend. It looks a bit like this here. Of course, this here is pseudocode. You can imagine it by looking at the name, do it Webpack, but more or less it looks like this. At least if you wrap the Webpack API nicely with some helper functions. Okay, and that's all. And I think the best thing about this is, one more time, the Angular shell is not aware about all of this. It is just doing lazy loading. The rest happens underneath. It's nearly too easy to be true. So there are also some more advanced scenarios. I have brought one advanced scenario with me. I'm calling it dynamic module federation. In our former example, the shell needed to know the micro frontends upfront, their names, and also their amount. But when going with dynamic module federation, we don't know anything upfront. We don't have to define remotes. We are just using the Webpack runtime API. Here I've wrapped it nicely because it's not that beautiful. You know, it's a low-level API, which is okay. And I assume most of you will wrap it with something like this. And when you look here, you see here I'm passing exactly the same information as before, but at runtime. That means I only need to know at runtime where the remote entry point of this micro frontend is. And I only need to know at runtime how it is called over there and which exposed file I want to load. So really straightforward, as you see here. Yeah, as mentioned before, this is a helper function I wrote. So let me show you a demonstration for this. For this, I will quit the web server here. I will move over there to my blue example. Where is my blue example? And here I will start another web server. Nice. Let's reload the page. And what we see here is a workflow designer. It's what I'm calling a plug-in based workflow designer. I can add some actions to my workflow. And the good thing is the workflow designer does not know those actions upfront. When the workflow designer starts, a lookup service is telling it where to find all those actions. For instance, this lookup service is telling that the download action can be found at localhost 3000 within a micro frontend 1, and it is exposed under the file name download. And upload is also found over there, but it is exposed under the name upload. Analyze, the analyze task is not located on localhost 3000, but on localhost 3001, and here we have the other key data. That means we don't need to know anything upfront. We can start the application. The application asks the backend, hey, which actions do you have for me today? Which actions are configured for me or for my current user? And then we get the key data and can use it to build a workflow. Quite a nice thing if you want to have an application which is extensible by third parties. Of course, this has nothing to do with micro frontends. It's the same technique, but it's not a micro frontend. But it's easy to assume that we don't load tiny actions, but bigger forms, bigger pages, bigger frontends. In this case, we could talk about micro frontends like in the example before. I really wanted to go with something like this to show you that module federation can be used for a huge amount of use cases, not only loading frontends. The technique is always the same. Okay, and how do I do this? Well, I grab this key data at runtime. I'm using this helper function, and so I get my Ivy component. Okay, so much about module federation. Perhaps you like this idea, like I do, and so you want to know when can I have it? And as a matter of fact, there is not an official roadmap, but let me tell you some facts we can use to estimate a roadmap. The thing is, Webpack 5 is currently in beta. And rumor says it will come out in late summer, perhaps in early fall. If this is the case, it comes early enough to be incorporated into the next CLI version, into CLI 11. Saying this, you cannot really use the beta version today. Even my proof of concept is using a lot of tricks. For instance, it is using a custom Webpack configuration. We won't do this. We want to let the CLI creating this custom Webpack configuration for us. And I'm also using a batched CLI version, not the official one, a batched one where Webpack 5 has been squeezed in. And I assume you don't want to use such a CLI version for production. So we need to be a bit patient. It is quite nice for a proof of concept, which is important for enterprise software, which is developed for years. So we need to know what we can get in the next month, but currently it's not production ready. As mentioned before, if everything is out there at the right time, then Webpack 5 will be here early enough to be used by CLI 11, which is due in fall. In the last years, it was about the end of November, perhaps the beginning of December. And when we have it, we only need to solve one issue. We need to find a way to squeeze in the module federation configuration into the CLI's Webpack configuration. We just need to extend it by this block we've seen before. But for this, we have solutions. We can create custom builders. A builder is an extension mechanism of the CLI. And by exchanging the builder, we can teach the CLI new tricks for ng build. And such a new trick would be to extend the Webpack configuration by the module federation parts and to tell the CLI, and now do what you are doing all the time, but with this new configuration. There are already solutions for this out there. For instance, you could look up my open source project, NGX Build Plus, which allows us to squeeze a partial Webpack configuration into the CLI's full Webpack configuration. So this is not a big issue, meaning time will solve all those points here. If you like this idea, then check out my free ebook. You can download it on my website. It's not only about module federation, it's also about alternatives to module federation, and it's about domain-driven design, which is a methodological basis for micro frontends. You need domain thinking to split your application into self-contained micro frontends. Okay, let me sum up. What did we see today? We have seen that the main purpose of micro frontends is scaling themes. We have more than one theme, and they have to communicate too much with each other. And so we want to scale them. We want to enable them to work independently. And please note, a good friend of mine told me themes is plural. That means you need to have more than one. Only then you will reach the sweet spot. If you only have one theme, please think twice before using micro frontends, because it brings additional ceremony. You have runtime dependencies, they can fail. So think twice before you use it. But if you have several themes, and as a matter of fact, today I spoke with a company in that area, then it will really be in handy. It also provides a decoupling between your micro frontends so that all the themes can work in isolation. Module federation is about importing stuff from another app on another origin. We can share libraries, so we don't need to load Angular 5 times when we have 5 micro frontends. And please take care of conflicts. This is the biggest challenge. And there is a last thing I really want you to remember, namely, try to be a bit like Bonnie. Bonnie was always thinking first, in opposite to her partner in this TV show, this guy with the muscles and the red buff trousers. He was always hitting first, and perhaps then he was thinking, or not, perhaps he was talking to his watch, I don't know, but she was always thinking first. And what I want to say with this is, please first of all evaluate whether you need micro frontends. If you don't need it because you only have one theme, then please go with a monolith. I know the microservice people are saying a monolith is something that's ugly, but other people are saying, hey, a monolith can be something that's beautiful. When you take care about it, when you are doing architecture work, when you make sure that the parts of your monolith are isolated, for instance, using linding, then it can be something really beautiful, something majestic. That's why those people coined the term majestic monolith. And if you say, yes, micro frontends really lower some pains we have, then I would recommend to consider module federation. It really introduces a revolution because it makes all of this really simple. So thanks for having me. Here you find my contact data. You can already download my material from my blog. I've already uploaded it. And yeah, thanks for having me. And Duda, I hope I have pronounced it in the right way. Duda.
Tuda, thank you so much. That was awesome. So we have a question from the audience. Let's see. No, actually, Adrian already got his or her answer. If you have questions for Manfred, now's the time. Again, thank you so much for your time and supporting the Israeli Angular community. We look forward to seeing you here one day. I want to remind everyone, again, we got a lot of great responses. Also for Daniel, we had responses before thanking him that it was a really, really great talk. We have a lot of thank yous in the comments. So thank you again very, very, very much. I wanted to remind you a few things. First of all, we still have our raffle. You can see below. You can see below the link to join the raffle. And also, just a second, let's see. See that there's a little bit of connectivity there. So you get 10% off your ticket to Angular Up. Let's see, we got another comment. We have a lot of thank yous. Yeah, people really like your talk. Obviously, this talk is recorded, so you can re-watch it again. And let's bring in Nir. Hi, Nir.
Hello. Yeah. Today,
how you doing?
Manfred, you're smiling.
Yeah, nice filter, Nir. So just a quick note, 500 Tech, the company is organizing this meetup, is recruiting. Join the team. Yeah, my cat is really taken into Angular these days, so she's joining my meetups. So if you're interested in hearing more information about joining the 500 Tech family, feel free to reach out to me. And also, if you want to speak at any of our future meetups, if you have something interesting to share with the community, even if you don't have a talk ready, Nir is super willing to help you compile a talk and share your knowledge. So thank you so much again, Manfred. And Nir, the stage is yours. After Nir's talk, we will have the raffle.
All right. So hi, everyone. So this is going to be 15 minutes about how we can do interesting stuff with Angular. The goal of this talk is to try to show you, teach you maybe something new, or just open your mind for a lot of possibilities we're building Angular component. So I'm going to do a very, very, very quick introduction. I'll jump right into the code. So first of all, thank you very much for Noor and Event Handler of keeping this community alive in these hard days. Yep. So thank you all. My name is Nir Kaufman. I'm a Google developer expert in Angular and web technologies, working at 500 Tech, co-organizer this meetup, Angular AL, for the past 7 years. And for all the Israeli community, watch out. There are some new things going on. So check out meetup.com and I'll provide more details later on. And that's my introduction. If you want to learn more about me, you can visit nir.life, where you can find the code that I'm going to write right now, and you can find the slide, and you can find all the contact information so you can keep in touch. And we're done. So I want to teach you one single technique, which it's not very popular, and hopefully you learn something interesting out of it. What I want to do. In HTML, we've got this video tag, which is great. So let me create a video tag. It can accept source, assets, video. I've got a video on my assets. That's the reason I can do it. I can give it a width. Let's say 600. I think it's cool. I can hit save. And that's basically all we need in order to play videos with HTML, which is cool. You can also add controls. And I think you're going to get the built-in controls. And that's super cool. But we want to build our own components, our own video players, and we would like to get some flexibility. Now, there are several techniques to achieve this. I can create my own video player component. I can create some kind of a special directive. I can wrap the entire thing with my own code and build my own buttons and control and stuff. But I want to show you something which, might trigger your imagination. So what I'm going to build right now, I'm going to create a file. I'm going to create an Angular component. You know what? Even a directive. Let's build an Angular directive. I'm going to call this directive video. And the first thing I'm going to do with this directive, once I get it, computer is a little bit slower today. Here you go. First thing I'm going to do with this directive is something that not a lot of Angular are familiar with. I'm going to use the video selector. So this directive going to be instantiated when you use the plain video tag. To prove it, let's make it more compact. And here I'm going to do log video directive instance, right? So look how cool it is. Down here, I'm going to go back to app. So you see I'm just using the plain video. Let's make this disappear. I'm using the plain video tag. And if I go to the console, you're going to see that, where is it? Where is my console log? Let's see if I actually use it. Selector video. Let's check the app module. Sorry, the app module, just to make sure that everything is registered. Here's the app directive. Go back here. Export the app directive. That looks to be okay. I suspect that I'm gonna need to recompile and hard reload, but let's give it a try. Once it's done, you're gonna see that just by creating a video, I'm gonna get a video component, video directive instance, which is cool. Sometimes it's relevant, sometimes it doesn't make any sense. I mean, if you're gonna create a directive and just use the selector div, I don't know what you can get out of it, but you see in a second why video does make sense, at least in my use case. So let's see if I was able to create an instance like what's my intention, and here it is, video directive instance. All right, which is cool. So what I'm gonna do with this instance once I created it, well, this directive is not gonna do anything at all. The whole purpose of this directive is just to create an instance every time you use the video tag, and that's it. So the interesting part gonna start right now. I'm gonna export a class. I'm gonna call it a video controller. This class gonna use as a base component, but there is no need for a template. I can use this. I agree, it's not so fun, I mean, to write code that looks like this. Oh, sorry. But I do need it to be decorated with component. Let's make this disappear. Inspection missing, disable inspection, cool. So now I've got this class, the name is video controller. And the first thing that I'm gonna do, I'm gonna use the view child, and I'm gonna look in my template for an instance of video directive, if it's there, right? And I'm gonna read it as an element ref, and that's gonna be my video element. Because when you use view child and you pass a type, you're gonna get the instance of this directive, and I don't want the instance, I want the native element. Now the rest of the code gonna be straightforward. I'm gonna create a play. I'm gonna create a stop, or maybe just pause. That's enough for now. And you can create, all the methods that you can think of, depending on your use case. And each one of those methods eventually gonna call this video element, native element, and gonna delegate to a native element methods. In this use case, it's play, and here it can be stop. And here you can run your own logic. Run your own logic. Right. And we're done. So what's going to happen right now? Let's say that you want to build a component that knows how to play a video. All you need to do is first create a simple plain video element. In the background, it's going to create an instance of the video directive. Next, make sure you extend the video controller to get all the methods you need in order to play the video. For example, let's get rid of those controls, and let's implement after viewing it. And when this component is initialized, I want to call this play. How to play, something like this, all right? And the video gonna play. Also, it seems that there is a very loose coupling between this video and this component. Let's say I want to create a button. I can stop it. Just give it some CSS classes. btn, danger, stop. And all I need to do is just call click. Sorry. Just call click and stop. Or even pause. All right. And I got it on my instance because I'm extending the video controller. Let's see if it works. Almost. Almost mean a hard refresh most of the time. Or just go back to my video controller and make sure, yeah, there is no stop, there is pause. That's gonna work, all right? Here you go. So let's summarize, and that's it. So this technique, I found it very, very useful because sometimes you build components that need to interact with some elements, and you've got few iterations. What's going to be the best API? What's going to be the fun and comfortable and the most transparent and understandable API that you can provide? And there's a lot of iterations and a lot of techniques and a lot of ways to achieve the same thing. In this example, I show you few techniques. First, how you can create a directive that used to expose an instance, so it will be easy to select and kind of override plain HTML tag. So every time you use the video tag, you just create an instance of video directive. And then how you can create a base component like video controller that look for this instance by type and then interact with it, which means that every time, everywhere in your app, if you build a component and this component needs to play a video, all you need to do is first create a plain video tag with everything you need, and then make sure to extend the video controller to get all the logic provided by the video controller. And this component will know how to communicate with this video element without all the extra API of passing properties and inputs and outputs and directives and templates and so on and so on. Yep. So that was it. I hope you learned something new. I hope if you've got any comments, if you've got some other ideas, please share it in the comments. Again, thank you, event handler. Thank you, Nir, for keeping this meetup alive. Hope to see you all guys soon, like the old days, so we can, get together. That's it, guys. Thank you very much.